Good afternoon, all of you. Today, I am going to talk on the topic thermodynamics from physical chemistry. Thermodynamics is one of the branch of physical science which deals with the study of quantitative relationship between heat energy and many other forms of energies. Quantitative relationship between heat energy and many other forms of energies like mechanical energy, electrical energy, light energy, chemical energy. Thermodynamics is one of the branch of physical science which deals with the study of quantitative relationship between heat energy and all these different forms of energy. Mechanical energy, which can be used in the working of machine. Electrical energy used in the process of electrolysis. Light energy, which is concerned with photography. Chemical energy, which is associated with chemical reaction. So all these energies are different and they are interconvertible into one another. Means mechanical energy get converted into electrical energy, electrical energy get converted into mechanical energy, electrical energy get converted into chemical energy, chemical energy get converted into electrical energy. Means all these energies are different and they are interconvertible into one another. Energy is nothing but the capacity of the system to do the work. So, in short, thermodynamics is nothing but the study of energy transformations accompanied with various physical and chemical processes. Means, whenever the physical and chemical processes are going on, at that time there is change in different forms of energies. There is change in when the physical and chemical processes are going on, there may be change in mechanical energy, change into another different forms of energy, or chemical energy change into different forms of energies. All of you. So thermodynamics is nothing but the study of energy transformations accompanied with various physical and chemical processes. In this year, in this topic, we are going to study free energy functions. The first, free energy function. We are going to study free energy function. Later on, we are going to discuss the derivation of law of mass action, one-top reaction isotherm and one-top reaction isochore. And next, the concept of activity concept, fugacity. And last, we are going to study Gibbs-Duhem equation. Okay? So, तर पहा या टॉपिकमध्ये थर्मोडायनामिक्स टॉपिक हा तुम्ही 12वी मध्ये अभ्यासलेला आहे, B.Sc 1 मध्ये अभ्यासलेला आहे, B.Sc 2 मध्ये अभ्यासलेला आहे, पुन्हा या वर्षी देखील तुम्ही अभ्यासता आहात. तर थर्मोडायनामिक्सचा अर्थ काय की हीट एनर्जी आणि ह्या डिफरंट फॉर्म्स ऑफ एनर्जी मधील जे रिलेशन ज्या फिजिकल सायन्सच्या ब्रँचमध्ये केला जातो त्याला थर्मोडायनामिक्स म्हटलं जातं. म्हणजे काय तर जर वेगवेगळ्या ज्या फिजिकल अँड केमिकल प्रोसेस होत असतात आणि त्या प्रोसेस होत असताना एनर्जीज ह्या ज्या डिफरंट फॉर्म्स ऑफ एनर्जी आहेत ते एका फॉर्ममधून दुसऱ्या फॉर्ममध्ये कन्वर्ट होणं आणि त्याचा अभ्यास करणं, ज्या ज्या ब्रँचमध्ये केला जातो त्याला थर्मोडायनामिक्स असं म्हटलं जातं. सो थर्मोडायनामिक्स इज वन ऑफ द ब्रँच ऑफ फिजिकल सायन्स which deals with energy transformations accompanied with various and physical process. मग या टॉपिक मध्ये तुम्ही काय अभ्यासणार आहात तर फ्री एनर्जी फंक्शन, लॉ ऑफ मास एक्शनचे डेरिव्हेशन, वन टॉप रिएक्शन आयसोथर्म, वन टॉप रिएक्शन आयसोक्रोर, त्याच्यानंतर कन्सेप्ट ऑफ ऍक्टिव्हिटी कन्सेप्ट, त्याच्यानंतर फुगॅसिटी आणि गिब्स डेम इक्वेशन, असे वेगवेगळे टर्म्स तुम्ही या टॉपिकमध्ये अभ्यासणार आहोत. नाउ आय एम गोइंग टू एक्सप्लेन टू यू फर्स्ट द गिब्स फ्री एनर्जी फंक्शन. फर्स्ट आर्टिकल, फ्री एनर्जी फंक्शन. फ्री एनर्जी फंक्शन. We are going to discuss the two free energy functions. The first one is Gibbs free energy function. Gibbs free energy function. And the second one, Helmholtz free energy function. Helmholtz free energy function. All of you studied in B.Sc 2. The new one of the thermodynamic function, that is entropy. So entropy is one of the criteria of spontaneity. So similar to this, in thermodynamics, new thermodynamic functions are introduced, which are the criteria of spontaneity. And what are these new thermodynamic functions? That is the free energy function. And there are two free energy functions. The first one is Gibbs free energy function. This Gibbs free energy function is given by scientist Gibbs, and that's why it is known as the Gibbs free energy function. And this Gibbs free energy function is denoted by the letter G. This Gibbs free energy function is also known as Gibbs potential. It is also known as thermodynamic potential. So we have to remember that Gibbs free energy function is also known as Gibbs potential, thermodynamic potential, and it is denoted by the letter capital G. The second free energy function, Helmholtz free energy function, and this Helmholtz free energy function is denoted by the letter capital A. This Helmholtz free energy function also known as work function. All of you. Now we see here. Now we are going to discuss. I am going to explain to you the first Gibbs free energy function and as well as the Helmholtz free energy function. Mathematically, both the functions are defined as G is equal to H minus Ts. G means Gibbs free energy function. H means enthalpy. T temperature. And S means entropy. So this equation gives the relation between G, H and S. And this equation is given by scientist Gibbs. So mathematically Gibbs free energy function is defined like this. G is equal to H minus Ts. Similarly, mathematically Helmholtz free energy function is defined as A is equal to E minus Ts. So this equation is given by scientist Helmholtz. And mathematically, it is represented by this equation. A, capital A, is equal to capital E minus T into S. In this equation, A, Helmholtz free energy function. E, energy, internal energy. T, temperature. S, entropy. All of clear? Now we see here, both this equation we have to know. That is, G is equal to H minus Ts. A is equal to E minus Ts. Now, we are going to study relation between, next point, we are going to discuss relation between G and A. Next point is the relation between G and A. So we see here mathematically G is given by this equation H minus Ts. A is equal to E minus Ts. In this equation G means Gibbs free energy function, enthalpy, temperature, entropy. A Helmholtz free energy function, E internal energy, T temperature and S entropy. Now we are going to discuss relation between G and A. So we see here, first we can write the equation G is equal to H minus Ts. Okay. Now we see here, H means enthalpy, and all of you studied the one of the equation by which we can calculate the entropy. H is equal to E plus PV. Now we can substitute the value of H in this equation. So this equation becomes G is equal to H is equal to E plus PV minus Ts. And what do you mean by E minus Ts? We see here E minus Ts, that is equal to A. So this equation becomes G is equal to A plus PV. तर पहा G आपण रिलेशन डिराइव करतोय G आणि A मध्ये. अतिशय रिलेशन सोपं आहे. G is equal to H minus Ts. H is equal to E plus PV. हे इक्वेशन तुम्ही 12वी मध्ये अभ्यासलेलं आहे. म्हणजे H ची व्हॅल्यू या ठिकाणी पुट अप करायची E plus PV minus Ts. आणि E आणि minus Ts म्हणजे E minus Ts म्हणजे A. मग E minus Ts A plus. So this equation represents the relation between Gibbs free energy function and A means Helmholtz free energy function. And for finite change means that is we can substitute the value of initial when the system is present in initial state and when the system present in final state, that is delta G is equal to delta A plus P into delta. So for finite change we can write this equation. So both this equation gives the relation between G and A. So G is equal to A plus PV, and for finite change delta G is equal to delta A plus P into delta. तर पहा हे फार महत्त्वाचे आहे की या टॉपिक मध्ये तुम्ही फ्री एनर्जी फंक्शन दोन अभ्यास करा. एक गिब्स या सायंटिस्टने दिलेलं म्हणून गिब्स फ्री एनर्जी फंक्शन, याला थर्मोडायनामिक पोटेन्शियल असं म्हटलं जातं. गिब्स पोटेन्शियल असं देखील म्हटलं जातं आणि हे जी ने डिनोट केलं जातं. आणि हेल्महोल्ट्ज या सायंटिस्टनी हे इक्वेशन दिलं A is equal to E minus Ts. त्याच्यानंतर आपण काय अभ्यासतोय ह्या दोन्हीमधील रिलेशन. मग G is equal to H minus Ts, H ची व्हॅल्यू E plus PV हे अभ्यासलेलं आहे, ते इथं पुटअप करा आणि हे फायनल इक्वेशन मिळतं. येते लक्षात? तर अशा पद्धतीनं हा पहिला पॉईंट आपण कंप्लीट केलेला आहे. याच्यानंतर चेंज इन G and A in isothermal process. Change in G and A in isothermal process. Changing G in isothermal process. Change in G in isothermal process. So this article is also very simple. So we see here, we know that G is equal to H minus Ts. Gibbs free energy function is given by this equation. G is equal to H minus Ts. So when the system is present in final state, then the Gibbs free energy of the final state is equal to, is denoted by the letter G2, is equal to H2 minus T into H2. Here, why we can write T as it is? It is because of we have to carry out the process at constant temperature. Isothermal process means the process in which the temperature should be constant. So when the system is in final state, then Gibbs free energy function of the final state of the system is denoted by the letter G2, and that is equal to H2 minus T into H2. And when the system is present in initial state, then Gibbs free energy is equal to G1 is equal to H1 minus T into S1. And delta G is equal to G2 minus G1. Okay. Now we can substitute the value of G2 and G1 here. So delta G is equal to H2 minus T into H2 and G1 H1 minus T into S1. Now we can simplify this. H2 here minus sign minus H1 here minus TS2 and minus TS2. We can take T common factor. So H2 minus S1. And therefore delta G is equal to H2 minus H1. Again we can write delta H, and H2 minus S1 we can write delta S. So this is the change in free energy. Change in free energy, that is Gibbs free energy in isothermal process when temperature is constant. So this is the change, that is the finite change. And for infinitesimal change, we can write delta G, dG is equal to dH minus T into ds. So this is the also change in infinitesimal change. म्हणजे हा फायनाइट चेंज सिस्टीमचा फायनल आणि इनिशियल स्टेट आणि इन्फायनाइट म्हणजे स्मॉल चेंज असतो, तर त्यावेळेला डेल्टा जी च्या ऐवजी डीजी लिहायचं आणि डेल्टा एच च्या ऐवजी डीएच लिहायचं आणि डेल्टा एच च्या ऐवजी डीएस लिहायचं. ऑल ऑफ क्लियर? सो दिस इज अबाउट द चेंज इन जी इन आयसोथर्मल प्रोसेस. मग अशाच पद्धतीने पहा चेंज इन फ्री एनर्जी, चेंज इन ए, change in isothermal process. Isothermal process. So what is the equation again? A is equal to E minus Ts. A is equal to E minus Ts. जर या इक्वेशन प्रमाणे तुम्ही जर इक्वेशन घेतलं तर डेल्टा A is equal to delta E minus T into delta S. मग पहा A2 is equal to E2 minus T into S2. A1 is equal to E1 minus T into S1. Delta A is equal to A2 minus A1. Now we can substitute the value A2 and A1. Delta A is equal to E2 minus T into S2. A1 E1 minus T S1. Final equation delta A is equal to next E2 minus E1 minus T into S2 minus S1, and final equation delta A is equal to delta E minus T into delta S. म्हणजे हे जे इक्वेशन आहे G is equal to H minus TS, इक्वेशन काय आलं डेल्टा G डेल्टा H T into delta S, आणि इन्फायनाइटसिमल चेंज साठी dG is equal to dH minus TL. अशाच पद्धतीने A E minus मग इथे काय येणार डेल्टा E मायनस टी इंटू डेल्टा एस. अशा पद्धतीने ज्या पद्धतीने आपण सॉल्व्ह केलं त्याच पद्धतीने. आणि इन्फायनाइटसिमल चेंज डीए, जसं डेल्टा जी च्या ऐवजी डी ची लिहिलं, डेल्टा एच च्या ऐवजी डीएच, त्या पद्धतीने डेल्टा ई च्या ऐवजी डीई, टी कॉन्स्टंट, आणि डेल्टा एस बद्दल काय दिलं डीएस, मग डेल्टा एस डीएस. सो दिस इज फॉर फायनाइट चेंज and this is for infinitesimal change. So change in Gibbs free energy function in isothermal process and change in Helmholtz free energy function in isothermal process. काही नाही, फक्त जी हे जी इक्वेशन आहे ना, डी च्या ऐवजी डेल्टा जी, एच च्या ऐवजी डेल्टा एच, आणि टी म्हणजे G2 ची आणि G1 ची व्हॅल्यू आणि ही वजाबाकी घ्यायची आणि हे इक्वेशन मिळतं. अशाच पद्धतीनं हे इक्वेशन द्यायचं. फायनल व्हॅल्यू फायनल सिस्टीम ज्यावेळेला फायनल स्टेट मध्ये असते त्यावेळेला ही व्हॅल्यू, सिस्टीम ज्यावेळेला इनिशियल स्टेट मध्ये असते ही व्हॅल्यू, आणि या दोघांची वजाबाकी घेऊन ह्या व्हॅल्यू येतात मग फायनाइट चेंज साठी आणि इनफायनाइट. ओके, I will continue in next lecture.